Hi, I'm Francis Hellier, and welcome to my podcast, Metaverse. Dedicated to the emerging world of the metaverse, this podcast aims to demystify and unpack the possibilities of the digital future just dawning over the horizon. In each episode, I talk to leaders in this growing space who are forging this new reality. From innovators in AR and VR, to futurists in crypto and space travel, and forecasters in business and tech. Together we'll ask the question, what's next? Today I'm joined by Sarah Milkovich, Trina Ray, and Kim Steadman. Sarah Milkovich is the lead of science operations for the Mars 2020 rover at the Jet Propulsion Laboratory. The rover is investigating the possibility of past life on Mars and the preservation of biosignatures within accessible geological materials. During her time at JPL, she has also worked on the Mars Phoenix landing spacecraft, the Cassini-Huygens mission, and the Mars Reconnaissance Orbiter. Trina Ray is an astronomer at NASA's Jet Propulsion Laboratory and a 33-year veteran of space missions. She started her career working on the Voyager-Neptune encounter, which found 4 rings and evidence for ring arcs or incomplete rings above Neptune. Trina has received numerous awards, including a NASA Medal for Exceptional Service, and is now a public speaker for the space agency. Kim Steadman is currently a system engineer for the Mars 2020 rover and the operations lead for the SHERLOC instrument, which uses cameras, spectrometers, and laser to search for organics and minerals that have altered by watery environments. During her time at JPL, she has worked on several other missions, including the Mars Exploration Rover mission, Cassini-Huygens mission to Saturn, and the Mars Science Laboratory. Sarah, Trina, and Kim, it's great to have you on the show.
Thank
you.
Much.
Yeah, thanks for
Great
having
to
us.
be here.
Thank you so much for joining me. If I can start with Sarah, what inspired you to follow a career in science and space?
I grew up fascinated by the rocks around me. Basically, my grandfather and my great-grandfather were iron miners in northern Minnesota. They got my dad into rocks, and my dad kind of passed it on to the rest of the family. So growing up, doing a road trip somewhere, we'd always stop and look at the outcrops of rock on the roads. And so just the sense that the rocks around you tell the story of the history of a place, but it's a history that's in another language, and half of the pieces of the puzzle are missing. So this was just really fascinating to me. And then I combined that with just enjoying stargazing, and then I found out you could put these two things together, this field of planetary geology. And so I kind of knew I wanted to get involved in space exploration and the science of that since a very early age. Have been delighted to be a part of that.
Amazing. And you, Kim, how did you get involved and excited about this wonderful thing ahead of you?
Oh, well, I grew up watching science fiction shows like the original Star Trek. It actually came out before I was born, so I'm not that old, but I watched reruns as much as I could. And then in 1977, this small little movie came out called Star Wars, and that was it. I wanted to go into space. And so I started reading everything I could about, the human missions to the moon and the Apollo astronauts, and I just couldn't get enough of it. And so that's when I decided I wanted to be an engineer.
And Trina?
I sort of stumbled into it. Well, when I was younger, my parents thought, oh, you talk a lot, you're probably going to be a lawyer. But then I ended up really liking science and math. And then I also found Star Trek and Star Wars, and all of my friends were really into science fiction. I read a lot of science fiction when I was younger. It's like a gateway drug too. And then you find out, hey, there are people that get paid to do this. That sounds crazy. And so then you go to school, and then I ended up in physics and then astronomy. And then I was local to the Los Angeles area, and I got a summer job working at JPL for the Voyager project and the Neptune encounter. That's kind of, how could you even plan that? And then that was just incredible to be part of that experience. And then it just fuels you.
Yeah, that's quite the stumble.
Yeah.
It was quite the stumble.
It's always good to feel in the room with geeks and sci-fi fans. It always makes me feel more comfortable. Sarah and Kim, you're both working on the Mars 2020 rover mission, which is aiming to find out if there was previously life on Mars. I mean, how cool is that? What are your thoughts on the mission? And do you think there's ever been or could ever be life on Mars, and why?
Well, I'm the engineer, so I don't worry about whether there has been life on Mars. It's just the rover has been fantastic. She has performed so great. We've moved so fast. We've done so much. We dropped a helicopter off on Mars, and the helicopter is still flying. We just did, I think, Flight 21 the other day, and it's just amazing. The challenges of operating such a complex machine so far away are just, it just gives me goosebumps just thinking about it. So there's always challenges, and it's so much fun to work on the mission.
Yeah, it's a very technically complex rover, and it's also very scientifically complex rover. And so putting those two things together has been one of the big challenges that Kim and I both, we work together. So Kim comes from the engineering side, I come from the science side, and we meet in the middle to try and figure out how are we going to operate this. And then as we are operating this, like what are the changes that need to be made as we're learning more about how our rover actually works on Mars. So the science of this mission is really incredible. We've been studying Mars with robots for decades now, and from everything we've learned from this whole fleet of rovers and orbiters and landers is that ancient Mars and ancient Earth were very similar to each other, and that both of them were very different from what either planet is like now. And we're talking about 3.5 billion years ago. That's the time period when life started on the Earth. So there's this question, if life could start on the Earth in that amount of time under those conditions, why couldn't it have started on Mars as well? In addition, one of the major differences between the two planets is that Earth has plate tectonics and Mars never has. So on Earth, we have very few rocks from that time period. Most of them have been recycled via plate tectonics. Mm-hmm. And Mars, over half the planet is that 3.5 billion years old, exposed on the surface. So it's this idea that we might actually find a better record of that time period on Mars than we can on Earth. So if we understand how life started on the Earth, if our theories are reasonably correct, we should be able to find the remnants of ancient bacterial life on Mars. If we don't find that on Mars, then that tells us that we're missing pieces of the puzzle here on Earth. And so sort of either way, it's a huge, huge amount of information. Like we have one data point about the starting of life, and this would make us have 2 data points about the starting of life, and that would just be fantastic. Yeah, I think it's probable, but probable not in a like high likelihood probability, but like maybe just slightly over 50% kind of, like, I think it makes sense that there was ancient life on Mars. But yeah, it is such a challenge to find these subtle patterns left by ancient bacteria. And that's part of why another exciting technological aspect of this mission is that we are the first step of hopeful Mars sample return. And Kim can talk more about like what goes into the sampling aspect and the science that leads to the sampling. But ultimately, we're hoping to have future missions that are joint with other space agencies to bring these samples back and study them here on Earth.
Amazing stuff. I'll take 50% anytime. That's really good.
Yeah, being the first step of Mars sample return is crazy. I mean, but we've already collected several samples, put them in the tube, and they're stored inside the rover, and we're hoping to drop those off in the next year or so.
We've got like 8 rocks,
yeah, it's
1 atmospheric sample, and a witness tube.
Yeah, and it's been challenging. Mars is always challenging.
Amazing stuff. Now, Trina, you've been a space mission veteran for 33 years. How has space travel and technology changed over the course of your career?
Oh, my goodness. Well, my first day at JPL, they sat me down in front of a machine that was called a card reader. And I had to learn how to operate that to get the data from the Voyager spacecraft. And I literally looked around and I said, I'm sorry, I don't understand what this is. So I've seen it go from card readers now to just incredible technologies that enable sort of space missions, just greater data rates, smaller instruments, better communication skills and processes and people with the scientists and the engineers working together over time, getting better. Every mission, you get better at it. It's a path. It's a journey. And there's no end in sight. I mean, when they had the little CubeSats that came along, and I was like, that's different. I wouldn't have expected that you could do something amazing with it. Something that's this, that's the size of your fist, and totally contributed to mission success. And so I just have nothing but sort of excitement about the future.
Yeah, that was the Marco satellites that went on the two CubeSats that went with the InSight lander, and then they relayed all sorts of data from landing.
It's amazing.
So cool.
Who would have thought, right?
Now, what are your predictions for space travel and technology? And what will we know about space in the next 10 to 15 years?
If we knew, then it wouldn't be fun trying to explore and figure it out, is kind of my, what
does Star Trek tell us? Yes.
Exactly.
Good point. Good point.
Yeah,
Um,
I'm hoping for more travel, more humans out in space, and like take your vacation, take your holiday on a space station and eat dinner, and that'd be fantastic.
that's
So
pretty cool.
yeah, it would be awesome because someone's building a
Mm.
public space station, so that's awesome.
So I think there's really two paths, right? There's the sort of the human exploration path and the robotic path. And I think they both have great futures in front of them, and you want both to be successful. And I think you will end up with, tourists in space and that sort of thing. But in terms of like moving the ball down the field for scientific and just exploration, the thing that NASA does that makes NASA unique in the sort of in the sphere, in the world of this exploration, is that we do things that are really, really hard. We do things that a commercial company would never do because there's no profit in it. And we do things that really move the ball down the field. And so you want that. I would love if NASA had double the budget and we were doing twice the number of missions and we were able to just keep trying hard things. I want to go to Mars and do a sample return mission. I want to go to Europa, and then I want to land on Europa, and then I want to dig into the ice of Europa, and I want to get to the ocean underneath Europa.
Yeah, we want to go to Neptune. We haven't had a dedicated Neptune mission ever.
Yeah.
And you look
giant
at
planets.
yeah, the giant planets. You look at what was it, New Horizons, when flew past Pluto and
Mhm.
discovered like nitrogen glaciers on the surface. That's amazing. So, yeah,
If you go somewhere you've never been before,
Yeah.
you're bound to learn something you did not know.
exactly.
And I don't think that people are going to be doing that. People are going to be controlling those vehicles. And boy, I would love to see, sort of more immediate control, right? Like a little bit more joysticking, but light time sort of defeats us in that way. And so it's always going to be, physics is physics. You can't get around that. But boy, I'm excited for the future.
Let's talk about your work. When most of us make a mistake on the job,
Mhm.
the consequences aren't that bad. If you ever make one, the result in terms of expense and scientific exploration are huge. How do you deal with that responsibility and obviously the pressure as well?
Well, you're very lucky that the all of our spacecraft have what we call fault protection software on board that are supposed to protect the spacecraft and the rovers from us, because we are one of the most dangerous things that any of our spacecraft interacts with, because we do make mistakes. So we have on the ground, we have what we call ground data system tools that everything we send up is checked to make sure that we're not violating any flight rules. The flight rules are written to keep the spacecraft and the rover safe. And you hope that when you do make that mistake and that command error makes it to the rover or the spacecraft, that the fault protection will save you. And that has been my experience. But the scary part comes when your spacecraft or your rover goes into what we call safe mode, or literally just doesn't talk to you. Like you expected to hear from Cassini at 2 p.m. There's no Cassini, what's going on? And then you have to look at the data that you've gotten in the past and try and figure out what could have happened. And so and then sometimes, like when we were dropping Ingenuity off on Mars, that's one thing, you kind of get one shot at it. And if the rover, after we drop the helicopter off, doesn't move out of the way, then the helicopter will expend its battery and could die. And you know that people have worked years to get this helicopter to Mars, and you're the one dropping it off on Mars, and you just have to put your blinders on, do your job, make sure you check everything that you're supposed to check, make sure you communicate with everybody about why you're making decisions, and you just hope for the best.
Yeah, a lot of it is the culture too, right? So sure, we depend on the spacecraft to have this safing, and that's critically part of the safety net. But we also depend on the processes and the people, and we work really hard to have, two sets of eyes on things that really matter. We work really hard to have that safety net where, okay, I'm not afraid to have somebody check my work. Yes, please check, right? And so you build it into the culture, and then if anybody sees anything, they say something out loud, and it brings the attention of the rest of the team to it. So you have people and processes and hardware and software and things on the surface of Mars, all those work together so that you make progress, and hopefully you don't lose very many vehicles.
So you kind of have to take ego out of the picture as well, don't you? Because it's such a collaboration between people.
Oh yeah, that's what makes it great, because it is a collaboration. You're on a team. The team succeeds or fails together, and it's just it's incredible.
And also you're working with really smart people, right? So like, if you had ego and you walk down the hallway and, there's Carl Sagan, right? It's like, yeah, okay, if you had ego before, you don't now.
Now, you three have some of the coolest jobs in the world, and it's such a pleasure to meet you today. And when people ask you what you do for a living, what sort of reactions do you get? Because I'm fanboying now.
First, what answer do you give? So that's the first question.
Sometimes, well, it depends on how I'm feeling. If I just say rocket scientist, I usually say I'm a scientist and an engineer for NASA is usually what I say. And then sometimes you get the somebody who's been following along with the rovers or something, and they get very excited. Sometimes you get why are we spending so much money out in space when we have problems here? And then sometimes you get one of the first public talks I gave, and somebody came up and asked me a question afterwards, which was, when is the rover going to drive to see the Nefertiti on Mars? And I had to figure out, because I had no idea what he was talking about.
Yeah.
And I didn't want to
be... When do the astronauts come back?
Yeah, I didn't want to be harsh somebody's joy in learning about space exploration. And so, but you also want to be the brain is really good at pattern matching. And there's sure, there's a dust blob somewhere, but also the rover can't drive that far. I think was ultimately what I told them.
It's really quite dependent on where the question's coming from, right? If it's coming from a kid, or if it's coming from somebody who's clearly interested, or if it's coming from somebody who's this is just sort of their first exposure to the fact that, hey, by the way, we collect our tax dollars and we fund NASA, and NASA sends, spacecraft all over the solar system. That's really cool. So it kind of depends.
My little niece is called Nesta, and she's 6 years old. And she, at the age of 3, could tell you all the moons of all the planets. So I talked to her this morning before we did the recording. She's so excited.
Yay!
And I think it's so wonderful that you guys can inspire a younger generation and hopefully take up the mantle, as it were.
Mm-hmm.
Absolutely.
Really cool. I mean, I think NASA, we actually have it in our mission statement, right, to inspire the next generation of scientists and engineers.
Yeah, it's really a gift that comes with our job, that we get to go out and talk to the public and tell them about what our wonderful missions do. And I think it's important that when people go to public talks, that sometimes they see women up there talking about what they do, and that the women that are talking actually work on these missions and make them happen.
Mm-hmm.
Movies like Hidden Figures show us that it took a long time for women to be accepted in space careers. How much better is the situation now, and is there still room for progress?
It's much better than it was. I mean, clearly. There's definitely still room for progress, because diversity is measured upon many different axes, right? So we're getting better at the sheer number of women in the room, but we're not very good at the number of non-white scientists and engineers in the room as part of the conversation. There's a different measurements of diversity, and I know that there's been studies that you need to be more than 30% of whatever your identifying population is, in order to not be the token person and feel that you are able to, speak up and make your contribution. So there's, I mean, even in the length of my career, I can see more and more women in both the technical and the leadership positions. But, I think there's still a ways to go.
There's definitely room to improve. So of course there's been improvement. When in the early days, you would get questions that were just that right now would make you cringe, right? In an interview, like, do you intend to have kids? How many, and how long are you going to be gone? Right? Today you would think to yourself, oh my gosh, I can't believe that question got asked. So there's definitely huge improvement. There's definitely room to grow. We still have all the things that Sarah talked about, but we also have pay inequities that still need to be addressed, even though we work at it all the time. When I was a technical group supervisor, then they showed you the data, and I'm like, that can't be. I sat in that meeting, and I'm telling you, that's not what happened. And yet, collectively, that group gave the women lower raises than they gave the men. And it's one of these unconscious bias things that you really have to work at, and you need the data to help you do that. So there's still plenty of room.
Now, you've all worked on some incredible missions. Which is your favorite and why?
It's like picking which of your kids is your favorite.
I can do it, though.
Go for it, Kim.
This one for me is an easy
Kim's
one.
got this.
It's the Opportunity Rover. She was just special. I don't know what it was about her. She was just, supposed to be a 90-day mission, and she lasted, over 15 years. And so every time you went into work, you didn't know what software issue you're going to run into, what failure you're going to have on the rover. But no matter what happened, she just kept going. And that team was just, by the time I got on, it was a smaller team. And so there was just so much camaraderie. And would do everything for this rover. And she just was special. And I think maybe it's because when Spirit and Opportunity landed, it was the first time that we had taken the images that come down from the rover or the spacecraft and put them right on the web for everyone to see. So to me, it was sort of like these rovers said, hey, I'm going to show you Mars. Come along with me, and you can be with me and see everything that I see. So it's just a special mission.
Mm-hmm.
That's my favorite.
Yeah, so sadly, I have to give two answers, right? So, of course, if you've ever worked on Voyager, that holds a special place in your heart because Voyager is sort of a mission of the generation, right? It's there is only one time in the history of your species that you send a robotic avatar that exits the solar system, and we were alive for that, and I worked on that mission. And it's just sort of like there's one time when man steps, or woman or human steps on to the ground of another body in the solar system. The first time. That only happens once, the first time. And people still remember it. People walking on the moon, right? And Voyager exiting the solar system. So that has to be, right, just the mission of your heart, Voyager. But I was very young when I worked on Voyager, and I didn't have a particularly important role. I had an interesting role, and I was very happy to do it. But on Cassini, I worked on that mission for 20 years. And I got assigned to the Titan group, which is the large moon of Saturn, very early. And was lucky enough to be assigned when the lead of that group was a woman scientist who just is absolutely like one of my heroes, Candy Hansen. And the way she works, how she solves problems, how she brings groups to resolution, right? I've learned so much from Candy over the years. And to be able to be sort of her right-hand woman for years, and then ultimately working on every single Titan flyby of the Cassini mission in ever-increasing important roles on the mission, that has got to be my favorite.
Trina, what does it mean to you? What did it mean to you to receive NASA's Exceptional Service Medal?
I was very excited. You go to these award ceremonies and you see other people get them and you're like, oh, wow, maybe one day. But really, they're quite rare. That happens every year, and there's only, a handful, 10, 15, 20 people that get them. So I was very excited. I was very excited to get mine, and for the Titan work was very special as well.
Amazing stuff. Sarah, tell us about you working on your first rover, Curiosity. What was that like for you?
So I started working on Curiosity about 6 months before it landed, and then continued for about 3 months after it landed. Everyone you get in this kind of panic mode as you're getting closer and closer to landing, because you're like, wait, do the software tools work? I was there to just help the science team figure out what the heck they were supposed to be doing, while how does scientists come in and help operate these things, and they're not embedded in the world of operations in the same way that the three of us are. And I was also, so it was just this, incredible adrenaline rush combined with, I was actually working part-time on Curiosity and part-time for the HiRISE camera on Mars Reconnaissance Orbiter, so Mars Reconnaissance Orbiter needed to listen to Curiosity as it was landing to relay the data, the engineering data from landing over. And then they'd also asked us to take a photo of Curiosity on the parachute as it was landing. And so I was basically kind of running between projects, but it was always doing things about this rover. So we'd started planning that camera picture 9 months before landing, because it was sort of, you had to, the spacecraft, the Mars Reconnaissance Orbiter, had to kind of do these wheelies in these ways that had never really been designed to point and operate. And, so we had to have the nav team and the flight team talking to each other, and then the camera team figuring out everything. We had to have all of this, all of the commands had to be uplinked at least 3 days, maybe longer, before the actual landing, before it was taken. And just the level of precision of knowledge of where each spacecraft was relative to each other and what their speeds were was astounding. And I just felt like just so amazed to be part of this team. And my job was, I was not someone who was, calculating trajectories or anything like that. But my job was somebody's got a question and they like I'm there to make sure that that gets carried over to somebody who can answer it, and that connection is made, and that we don't drop pieces along, we don't have loose threads that people forget about. So that led to me doing a NASA press conference the morning after landing, because I was the member of the high-rise team who was at JPL. I was also up all night because it was landing night. So being very sleep deprived and telling people about this picture that we'd taken on Mars was very much a career highlight for me.
And it was a great picture too.
It was.
That was just crazy, right? When they sort of, it was strips and everybody's looking at the strips to find the little, parachute. But then when they put all the strips together and you saw it with the crater in the background, oh, I cried. It was so beautiful. It was so beautiful.
And watching the press conference, that's Sarah. I know her.
It was awesome too. I was so proud. You did such a great job.
Thank you.
Kim, you started your career at NASA just after graduate school. What was that like for you? And what was your most memorable story from those early days?
Well, I remember I was hired on a technology project, and I remember one of my first meetings with the whole team, and people were talking, and I didn't understand what they were saying. It didn't even sound like English. And so I thought, they've made a problem. They've hired me, and I'm obviously an idiot because I have no idea what they're saying. But because JPL itself is an acronym, and every spacecraft has its own acronyms, and so there's acronyms on top of acronyms. And so I actually went to my boss, and I was like, I'm sorry. I didn't follow anything in that meeting. And she was like, give it 6 months. And I'm like, oh, so it's not just me. So then I had to start taking lists, making lists of when someone used an acronym, I'd write it down. And then afterwards, I would go on my computers, back before we all had laptops that we walked around with, and I would look up what that acronym was and just try and learn what the heck people were talking about.
Now, what does the future hold for you all?
So I'm currently on the Europa Clipper mission, which is just a really exciting mission. We're in the building phase. So we are a couple of years away from launch, and we are going to launch in October of 2024 and get to the Jupiter system in the early 2030s. And that'll just about be the time I'm in the retirement stage, but I am staying through Prime Mission, of course. The nice thing about working on Europa is that now maybe I'll get some of these questions about, do you think there's life in the solar system? Because Europa is one of those places where we really have a very interesting place to explore a chance of habitability in that ocean that's been broiling and roiling away for several billion years, with a lot of chemistry, a lot of energy, a lot of the things that you need to create life. So very excited about that. So I intend to stay on Clipper all the way to the end.
Amazing stuff.
So I'm on the Mars Perseverance rover, of course, and we just completed 1 year on Mars, and our prime mission is for 2 Earth years on Mars. And so I at least plan to stay on the mission for another year, hopefully 3 or 4 if she keeps going like Curiosity has. Curiosity, I think, is at 9 years on Mars now. And so I just hope to keep going with Perseverance and keep learning and operating the SHERLOC instrument.
Much of what I'm doing I'm still on Perseverance, and I'm helping the science team. When they feel lost, they email me, and so that's sort of the near future. I'm gonna be continuing to do that. I don't know what my next project after that will be. I'm kind of in this the ride of the whole Perseverance experience was a long. It wasn't even a marathon. It was one of those ultra marathons, through the mountains kind of thing. And so I'm taking a little bit of time to contemplate what do I want my next adventure to be. But one thing I am looking forward to, the other people picking up the torch of these samples and bringing them, and hopefully, somebody who's, maybe your niece, she'll be able to work with these samples in the future.
You three are such inspiring ladies, and I'm so honored to have had you on the podcast. I just wanted one last question, which is the younger audience that's listening into this. What advice would you give them if they wanted to follow in your footsteps?
So I'd say the first piece of advice is what you've heard here is 3 very different paths. And so there is no one right way to find a work that is inspiring and or work at NASA. But you do have to go to school for quite a long while, so you do need a technical background. And then when you go after those summer internship jobs in your college years, be sure to try try different things because you don't know exactly what you're going to like. But try different things in those summer internships. And then when you get your first job, just put your all into it. Volunteer for everything. You're the one who has the time. Everyone else has their plates are full and they're happy to shed things. And also they're happy to talk to you. Don't even hesitate when you get your first job to start having quiet hours with people that you just randomly heard somebody's name and you thought what they did was interesting. You have no idea how many times we get phone calls from somebody who's just started at JPL and says, I'd like to have a quiet hour with you. I just want to talk about your career. I want to listen to things. I want to hear what you might tell me. And everybody is usually really happy to do that.
They're like, help me out with these acronyms, please.
That too.
Yeah, so my advice is don't ever give up because we're all told no. We all fail at something that we try and do. Don't take no as the final answer. When I applied to graduate school, they sent me this very nice letter that said, no, we are not going to take you in graduate school. So I picked up the phone and I called the head of the department and explained to them why I thought they had made a mistake. I'm not sure what was wrong with me that day, but I did it. And I got into graduate school and I graduated. And so, yes, don't take no for an answer. There's always several different paths to get where you want to go. And when you start your journey, you have no idea where your path's going to take you. So just keep at it.
Yeah.
Similarly, not only don't let other people tell you no, don't let yourself tell you no. I think many of us, especially growing up, had that little voice in the back of the head being like, oh, this is going to be really hard. This is going to be scary. I don't fit in. And just ignore that voice entirely. There's going to be enough other people putting obstacles in your way. Don't create more of them. Don't create obstacles for yourself.
And find peers, right? Find peers who can help you. Find mentors who can help you.
Just people that support you, people that will tell you, yes, you can do it, because it's shocking. That's one of the biggest realizations, and I'm not really feel like I'm an adult, but my adult life is finding out that other people have these insecurities and think that they're not good enough.
Yeah, like we were fortunate enough to chat with a lot of really amazing people, and then you find out how insecure they are about their capabilities, and we're like, no, but you're awesome, you're amazing, I want to be like you when I grow up. And so we still have that feeling looking at our coworkers as well.
You've been listening to Metaverse with me, Francis Hellier. Thank you to my guests, Sarah Milkovich, Trina Ray, and Kim Steadman for a fantastic conversation. Tweet us at Metaverse Pod with any suggestions or feedback, and if you enjoyed the podcast, please share a link on social media. You can sign up to receive an email when a new episode drops at our website, metaverse.fm.